Hi everyone and welcome back. In this video we're going to go over two sentences here, not P and not Q, and compare it to the sentence not the entire quantity P and Q. So we have to figure out whether these sentences are logically equivalent, which is why this is kind of a harder example. So what we need to do is create the table for this and the table for this and then see if they're the same. That will make them equivalent. So let's do it. So we have two variables here, P and Q. That's normal, so we always do this. P, let's do capital P, Q. This is all going to be standard, right? It's always true, true, false, false. If you're not sure about this part, I'd recommend going back to see other videos. This is kind of the same every single time. And now we say, what variables do we need for this? We'll go one sentence at a time for this one. Not P and not Q. Well, we have an AND statement, and it's separated by two pieces. One piece is not P, so we'll put that here. Not P. Oops. And then the next one is not Q. Okay. So these two things make up this full sentence, not P and not Q. So let me just copy that and paste it right here. Okay, and we're going to compare that statement to this one. We're getting there. So let's first symbolize, or sorry, let's first fill in these cells that we just symbolized. So not P. Remember, this is the opposite of P. So my eyes immediately go here, and I see P is true. That means not P is false. P is true, not P is false. P is false, not P is true. P is false, not P is true. Same idea here for not Q. Right? My eyes go here now, which is Q. And I'm saying I need to look at the opposite of Q. So true will turn into false. False will turn into true. This true will turn into false. And this false will turn into true. Great. So now I have not P and I have not Q. And this is an AND statement that compares these two pieces. So my eyes look at these two columns and they say, okay, the AND condition is only true when both pieces are true. So let's do it one by one. Both of these are not true. That means this is false. Both of these are not true. That means this is false. Both of these are not true. That means this is false. Both of these are true, which means this is true. Great. So this is our truth table, and I'll use a different color for our first sentence here. Great. Now we need to compare it to this sentence. So we have not the entire statement P and Q. So let's build up to that. The first part is this inner P and Q. Let's put that right here. And then we're going to be building up to this not. So that's going to be the full statement. We're just going to be negating. And let's bold these just for consistency. Okay. And it looks like the font's a little messed up, but that's okay. You get the idea. So, P and Q. I look at P, I look at Q, and I run that same truth condition. P and Q is true when both pieces are true. So true and true, right? These two, P and Q. True and true gives me true. True and false gives me false. False and true gives me false. False and false gives me false. Great. Now we're almost at this final form here. We have one more step. We have the not symbol in front of this whole quantity. That means this entire statement P and Q is getting flipped. It's getting negated. So now this true will turn into a false because we're flipping the truth value. The false will turn into a true. This false will turn into a true. And this false will turn into a true. So this, I'll highlight this in a different color. This is, let's do blue. This is going to be the statement, not P and Q, the table for it. So the question was, compare these two statements. Are they logically equivalent? Well, the answer is no. Now, how do I say that? Well, this is false, this is false, this is false, this is true. These are not the same. That's what I'm trying to say. In particular, these two, I'll just highlight them maybe. They're different. Right here, they're different. Because they're different, we can say that they're not logically equivalent. So this is a hard example because it takes what you know of symbolization and it applies a little bit extra layer of comparing two things. So it's kind of a 2-in-1 kind of problem. So the answer here is no, they are not logically equivalent. Hopefully you learned a bit about the truth table, and again, just building it up step by step. Start with this frame always, and then just start building until you get to the full statement itself. Hopefully that helped. If you have any questions, let me know. I'm going to do some more examples, so stay tuned. But that's it for now. Thanks.